Database environment. Objectives of the tree-level architecture. All users should be able to access same data. A user's view is immune to changes made in other views. Users should not need to know physical database storage details. DBA should be able to change database storage structures without affecting the user's view. Internal structure of database should be unaffected by changes to physical aspect of storage. DBA should be able to change conceptual structures of the database without affecting all users. These are the figure of answers part tree-level architectures. The levels form a tree-level architecture comprising an external, conceptual, and internal level. The way users perceive the data is called the external level. The way the DBMS and the operating system perceive the data is the internal level. The internal level is where the data is actually stored using data structures and file organizations described in. Conceptual level provides both the mapping and the desired independence between the external and the internal level. Answers part 3 level architecture's definition. External level. User's view of the database and describes that part of database that is relevant to a particular user. The external level consists of a number of different external views of the database. Each user has a view of the real world represented in a form that is familiar for that user. The external view includes only those entities, attributes, and relationships in the real world that the user is interested in. Other entities, attributes, or relationships that are not interested may be represented in the database, but the user will be unaware of them. The next one is the conceptual level. Community view of a database. Describe what data is stored in database and relationships among the data. The middle level in the tree-level architectures is the conceptual level. This level contains the logical structures of the entire database as seen by the DBA. It is a complete view of the data requirements of the organization that is independent of any storage considerations. The third one is the internal levels are physical representation of the database on a computer and describes how the data is stored in the database. The internal level covers the physical implementation of the database to achieve optimal runtime performance and storage space utilization. It covers the data structures and file organizations used to store data on storage devices. The data independence. Logical data independence are first, refers to immunity of external schemas to changes in conceptual schema. Conceptual schema changes, example, addition, removal of entities. Third, should not require changes to external schema or rewrites the application program. Physical data independence are first, refers to immunity of conceptual schema to changes in the internal schema. Internal schema changes, example, using different file of organizations, storage structures, and devices. Last, should not require change to conceptual or external schemas. Data independence in the ANSYS Spark three-level architectures. In the figure below, the two-stage mapping in the ANSYS Spark architecture may be less efficient but provides greater data independence. However, for more efficient mapping, the ANSYS Spark model allows direct mapping of the external schemas on the internal schema. Thus, bypassing the conceptual schema, this, of course, reduces data independence so that every time that internal schema changed, the external schema and any dependent application programs may also have to change.